And I just want to welcome everybody to our Exchange 2013 webinar series, hopefully soon to be Exchange 2016. And we're going to look at the insights and best practices for running Exchange 2013 on VMware. So my name is Sean MacArthur, and there is my email address. If you guys have any questions after the presentation, please don't hesitate to send me an email. If you have any questions during the presentation, please post them up in the questions section and I will answer them when I get a chance. So I've been doing this for a while. I've got several certifications from VMware, from Microsoft, and from several other companies. I started teaching Microsoft in 1996, then moved on to Exchange around 1996 or 7, somewhere in there. It was around 5.0 when I started with that. Got into VMware around 2005, developed a bunch of tests. I've developed actually over 30 exams for Microsoft, so pretty familiar with it, but doing this for a little bit. Around 2002, 2003, got into consulting pretty heavy and traveled around the world doing Exchange and Active Directory migrations for several large companies all over the world. More recently, I got into doing disaster recovery implementations through VMware, through regular physical DR implementation, so doing replication for VMware, for physical, for virtual, for all kinds of stuff. So that's been something I've been doing pretty heavy, and quite a bit of VMware consulting as well. So one of the things that I've noticed is that every time I go to a customer site, I always see some interesting stuff. And this is why I like consulting. When you do training, you teach a class, every class is exactly the same, a couple different questions this week to that week, but all in all, it's the same thing, monotonous over and over. When you do consulting, I'll go to 5 companies that are exactly the same, but every time there's just a ton of differences. And I've seen a lot of things with Exchange, whether it's physical or virtual. When we look at Exchange, one of the things that we've been taught to do is separate the databases and the log files, which you should do most of the time, but there are times when you may not need to do that, depending on how your DAG's set up and how many copies of each database and things like that. Backups. This is something I've seen that's been horrible for companies. I have one company that took 36 hours to do a backup, and they were doing backups every 24 hours. So yeah, that was a big problem. Seeing tons of storage and networking misconfiguration. I have one company had a SAN that was iSCSI. They had 8 NICs on their iSCSI SAN. All 8 were plugged in, and how many were being used? Just 1. So they had no multipathing configured. They had no failover, redundancy, all kinds of different problems. One of the things that I find is difficult with virtualization and VMware and Exchange and all of that is Microsoft, as an example, says this is how you're supposed to run Exchange 2013. And then VMware says this is how you're supposed to run virtualization. And then NetApp says this is how you're supposed to do storage. And none of these things align. So what do? Do you follow NetApp? Do you follow VMware? Do you follow Microsoft? Where do we go with this? So you need to work with your SAN, you need to work with your virtualization vendors, and you got to work with Microsoft, because ultimately Microsoft is going to be the one that's going to support you, but they're not designing for a VMware environment. In fact, Microsoft's recommended environment nowadays is running on physical servers with local JBOD storage. So that is their recommendation, and that's what they're using for Office 365. Now, a lot of times I get called in for lots of reasons. During migrations, I'll get called in. What I like is before the migration is started, and then I will architect the migration, and then I will actually implement the migration. Sometimes I'll just architect it, someone else will implement it, and sometimes someone else will architect it, and then I will implement it. And the worst one is when someone else architects it and implements it, and then they call me because it's all screwed up and want me to fix everything. So we developed a class that we call the Microsoft Exchange Ultimate Bootcamp. And right now it's built for Exchange 2013. And one of the reasons I did this is about 2-3 years ago, I was attending VMworld, and I sat through a presentation of best practices for running Exchange on VMware. And I learned some really neat stuff, some stuff I already knew, but I realized that 65% of the Exchange implementations are currently running on VMware, but 100% of the Microsoft training is done on Hyper-V. And I asked one of my friends who was also an Exchange trainer but knew nothing about VMware how he would do some of the things that they talked about, and he had no clue. And I'm just thinking, here's these guys who know nothing about VMware teaching this Exchange class, and they're giving misinformation to 65% of the students that are running their stuff on VMware. So we built a pretty neat class. Now, I don't want this presentation to be a sales presentation. It's meant to be technical, but just kind of going into what we've done, why we built this class. So let's look at some best practices for running Exchange 2013 on VMware. Now, before I move forward, how many people here are currently running Exchange 2013? If you go in the question and answer section and put just yes or no for that. Okay, so about 50-50. How many people here have ever seen Exchange 2016? Yes and no for that. The amazing thing about Exchange 2016, when you look at every version of Exchange that's come out, they've had Exchange 2000, 2003, 7, 10, 13, and each one of these made a version number change. So from 11 to 12 to 13, 14, 15, and they're currently, Exchange 2013 is on 15. When we look at Exchange 2016, and I actually have an environment set up here with Exchange 2010 and 2016 over here, and I've got the management interface set up here. If we look at this, this is the management interface for Exchange 2013. You'll see we've got recipients, permissions, mailboxes. We got a bunch of users over here. That's cool. And over on this tab, I have an Exchange 2016 server. Whoa, it looks exactly the same. And it is. It looks almost exactly the same from 2016 to 2013. If you go back here, you'll see when I click on servers, that this is version 15.0 and the build number, which I'm guessing, but I think that is Service Pack 1. Over here, when we look at this server over here, we've got a couple servers. We got a 2010 box over here, which is version 14, and Exchange 2016, which I know it says Exchange 2013 here. It's the name of the actual server is Exchange 2013. I just kind of renamed it in here to 2016, but it really is 13. But it has actually got Exchange 2016 installed on this guy, and it's version 15.1. So a lot of people are calling this Exchange 2016 as like an Exchange 2013 Service Pack 2, because it's really not that different. They didn't even change the version number, still a 15. So first time I've ever seen them do that. But back to this. When we look at some of the changes and new features that came out with 2013, and we're going to talk a couple of things before we jump into the VMware stuff here. They redesigned all the management. So they got away from the Exchange Management Console of 2007 and 10 and went to the what they call EAC, Exchange Admin Center, which is a web-based management interface. And the concept is great. We can use any device, connect to Exchange, manage it from everywhere. It's laid out extremely well, and it was built by someone who's extremely colorblind. There are no colors in there, and it's difficult to differentiate some things because there's no separation of tabs and columns and things like that. So I like the way it's laid out, but again, some things could definitely be done better. One of the big changes is in Exchange 2007, they came out with 5 roles: the client access server role, mailbox server role, hub transport, unified messaging, and the edge transport. With 2013, they came out with 2 roles in the RTM version, just the CAS and the mailbox server. And with Service Pack 1, they brought the Edge Transport. Well, in 2016, they only have 1 role, and that's the hub transport. Excuse me, that's the mailbox and the CAS are all rolled up in that 1 role. Then they do have a Edge Transport separate, but just have those 2 roles. So everything's combined on the 1 server now. No separation of roles like we used to have in 2010. Also, you're seeing a lot of people who are thinking, looking, or at whatever extent talking about Office 365. And they have what's called a hybrid deployment option where you can have some users local to your on-premise servers and some users on Office 365. And you're able to manage these users through one console, through that EAC or through the command line, which is the management shell. So they've got that built in. And like one of my customers, University of Florida, has 8,000 on-premise users and 26,000 in Office 365 because Microsoft's running a deal where all of the students get Office 365 for free. So they're offloading that. They did change how the store exe process works. Now there's a separate worker process for each database, which makes it more robust, number one. Also makes it more resilient in case of crashing, which is nice. Public folders, these guys have been all over the place. With 2007, they were gone. Then they brought them back. 2010, they were still around. 2013, they completely redesigned them. They got rid of the public folder database. There's no public folder management console. There's no replication of the public folder database. What they did now is they created what's called a public folder mailbox, and then your public folders exist within these public folder mailboxes. And you can have more than one public folder mailbox depending on how many public folders you have. So because it's a mailbox, it exists on a regular mailbox database, and it's protected through a DAG, which is a clustered group of Exchange servers. They you can use OWA to check your mail, and that's been around for a long time. It was called Outlook Web Access. In 2010 or 13, I can't remember where, they renamed it to Outlook Web App, and in 2016 they've renamed it to Outlook for the Web. So they're just not quite making up their mind. Cool thing is it now supports offline. Just like you could take Outlook and use it in cached mode and it would download your mailbox and store it in an OST file, you can do the same thing with the HTML5 browser, store it in an OST file and use OWA offline. Has support for up to 8 terabyte disk, built-in anti-malware, all kinds of stuff like email retention policies, archiving, legal hold, e-discovery. So kind of cool stuff built right in. And there is the EAC, which we looked at. One of the things for those of you who haven't gone to 2013 or haven't even gone to 2010 yet, had a kid yesterday who was still running 2003. I would strongly suggest that you work on using the shell. I'm not a Linux guy, so I'm not a huge command line dude, but there are certain things that are more efficient to run through the management shell. And once you learn PowerShell, whether it's for Exchange or Windows or whatever it is that you're doing, the concept is the same, and you'll see it'll really help out with some of the things you can do and just speed things up. So 50% of the labs we actually do in our class are written in PowerShell, and believe it or not, the last 3 Exchange migrations I have done, the entire migration was done through PowerShell. So not just moving users, but the setup, the teardown, everything was done through PowerShell, and it was much faster. So kind of cool. So let's get into some of the meat and potatoes while you guys are here, which is how do we want to effectively run Exchange on top of VMware? Now, first off, virtualization got to be real popular around 2007, and obviously it's gained in popularity since then. But I started putting Exchange 2007 on VMware. What was supported with that? Nothing. Really nothing. And we had problems where we would call up Microsoft and they wouldn't support us because it wasn't a supported platform. With 2010, it's pretty much fully supported, and with 2013, it is 100% supported, as well as with 16. So one of the things we're talking about here is on the first bullet point, CPU overcommitment is possible and supported, but approach conservatively. CPU overcommitment. What are they getting at here? Well, let's look at this here. If we go and, whoops, we draw a motherboard and we draw a CPU with a core in it. What they're saying is, let's just say I have a single core CPU and I've got a virtual machine over here with a single virtual CPU, and the virtual machine goes to the VM kernel and says, hey dude, I want to access the physical core. So he goes over here and tries to access the physical core. Well, now another VM over here says, I want to access the physical core. Well, this guy has to wait. He contacts the VM kernel and then he has to wait. Now we got another guy over here and another guy over here. Well, theoretically, VMware's numbers support that you can have up to 32 virtual machines with 32 virtual CPUs accessing each core. Now, they're not accessing it simultaneously. When VM number 1 is accessing it, VM number 2, 3, 4, and whatever are all waiting to access it because the core can only do one thing at a time. So it's kind of inefficient. So going back to the slide and what they said here, the ability to have multiple CPUs accessing that one core is called overcommitment. And yes, I could have 32 virtual machines waiting to use that core, but 31 of them are going to constantly be waiting while one is actually working. So it's going to be fairly slow. Now, if you're running an Intel processor, they have support for what's called hyperthreading, and you should turn that on in the BIOS of your physical machine. And hyperthreading just says, hey, I got a single core, but I can run two things at that core at one time, as long as those things are small. So if one of those VMs wants to run Notepad and the other one wants to run FreeCell, yeah, no problem. We can throw both of those at one core, no big deal. However, if VM number 1 is running a really heavy SQL server and VM number 2 is doing a real big something on VM number 2, it's going to give exclusive access to one of those VMs. It's not going to allow you to split up that CPU, so it will just grant that to one VM. Now, with vSphere 5, it came out for support of what's called NUMA. We're going to talk about it on this slide and a little bit on the next slide. But NUMA is not understood by Exchange, but it is understood by VMware. And what this is saying is, if we go here and we look at my beautiful drawing of a motherboard, we've got 2 sockets on here with, let's say, 4 cores per socket. Then we've got some RAM over here. All right, and kind of break this in half. The top, we'll call this top and we'll call this bottom. Each one of those is a NUMA node. So let's say I've got 8 gigs of RAM here and 8 gigs of RAM here. In this particular scenario, I would not want to build a single VM larger than 4 virtual CPUs and 8 gigs of RAM. Otherwise, it's going to have to cross the bus on the motherboard to access the other NUMA node. So I want to try and consolidate to where my VMs will all run within a single NUMA node. It's not a requirement, but it's something you should do to get the absolute best performance out of your VMs. So like it says, if your NUMA node is 8 cores, keep the VM under 8 cores. So in my drawing, we had a 4 node or a 4-core NUMA node, so we'd want to keep our VMs under 4 cores. Now with vSphere 5, they came out with the ability to say, all right, I'm building my VM, and I want to decide how many, not just cores I'm giving to the VM, but how many sockets I'm giving to the virtual machine. So back in vSphere 4.1, we would just say I want to give 4 virtual CPUs to the VM. Now we're saying, okay, well, I want to give 4 sockets to the VM with 1 core per socket, or 1 socket with 4 cores per socket. So the question becomes, so what? I'm giving 4 cores to the VM either way, so should I choose 4 sockets and 1 core, or 1 socket and 4 cores, or 2 and 2? And the answer is, you should always go with 4 sockets and 1 core versus 1 socket and 4 core. The only time you would ever choose 1 socket and 4 cores would be if you're running some sort of program like SQL 2008, where it's licensed per socket. So if I built this box here like this with 4 sockets, 1 core for SQL 2008, I'd have to buy 4 SQL licenses. If I built it with 1 socket and 4 cores, I'd only have to buy 1 SQL license. Now, with newer versions of SQL, I can't remember what versions, but I know 2012 and 2014, they got to the point where they're licensed per core, regardless of how many sockets you're split up into. So with 2014, it doesn't matter, but with the older versions, it does. Now, it's interesting here. A lot of this was taken from Microsoft. Some of this was taken from VMware and other places, but from Microsoft, they're saying allocate 2 virtual CPUs for every physical core. So 2 times overcommit is supported. So what they're saying is, if I mentioned that VMware says you can have up to 32 VMs on a single physical core. And Microsoft's saying, yeah, that's great that you can have that many theoretically, but we don't want you to have more than 2. So if I've got an 8-core box and I build all my virtual machines with, let's say, 1 core, 1 virtual CPU, they're saying you can have more than 16 machines running on that box. If I build my machines with 4 cores, that means I couldn't have more than 4 VMs running on that 1 box based upon what they're saying. Now, what I'm saying is this: monitor it. Maybe this is true. Maybe it's not. But you need to monitor it, and you need to see, what are the other VMs doing? Are they very CPU intensive? The one thing I will say about Exchange, it's not a really CPU intensive application. So you can actually get by with higher overcommitment rates. When you look at networking, there's a lot of things you have to design when you're building this. You have to design your physical network infrastructure to work with VMware. You have to design your ESX host networking. And then you have to design the networking within your virtual machine. So a lot of things you have to design when you're working with this. From the physical side, all of your decisions are really made based upon VMware. From the virtual side, when you build your Exchange virtual machine, you have the choice to add some network cards to the VM. And we have some types of network cards that we can add. And the types are like Intel E1000, Intel E1000E, VMXNet NICs. The newest VMXNet NIC is VMXNet 3. And these are just NICs built by VMware. And since they're built by VMware, there's no drivers for these built into the Windows operating system. So when you build a VM and put Windows in there, you install VMware tools, and then it'll bring in the drivers for these VMXNet 3 NICs. And these will be the highest performing NICs. So you want to build all of your Exchange VMs with VMXNet 3. And I've never ran into a problem where there was an Exchange VM had a problem using VMXNet 3. So use that. Now from the host VMware side of the house, VMware has several options for virtual switches. They have standard switches, distributed switches, and even third-party switches from other vendors like Cisco and IBM. And from an Exchange perspective, it doesn't matter. If you want a standard or distributed, that's a VMware decision, not Exchange, and it will work with either one just as good. Just make sure they're load balanced. You got a couple of NICs in case of failure, and then everything's configured correctly. But that's more of a VMware thing, not an Exchange thing. On your VMs, make sure that you have your VMware tools installed. If you run on Hyper-V, make sure you have Hyper-V integration installed on that as well. And Exchange works with VLANs, works with 10 gig, works with all that stuff. The next few slides here I find are really interesting. When we build a VM in general, we're going to add a SCSI controller. Now, this is a virtual SCSI controller for our virtual machine. And we have 4 types of SCSI controllers. We have a bus logic, which is old, and you should never use it unless you absolutely have to. But nowadays, you should never use it. We have 2 types of LSI logic. We have a parallel and a SAS. Now, 99% of the time, you want to use LSI SAS for everything. But there is a 4th type of adapter called VMware Paravirtual. And what this is, just like the VMXNet NIC, which is a NIC built from VMware, specifically for VMware, they have the same thing here, a Paravirtual adapter. Well, it's built from VMware. for optimal performance? Well, because it's built from VMware, there's no drivers in the OS. So typically what we'll do is we'll get an OS installed up and running. We'll install VMware tools, which now includes the drivers for the paravirtual. So when you think about it like that, we really got to kind of have the C drive up and running, and then we use the paravirtual for any data disk that we have. They did make it possible in newer versions where you can actually boot to a floppy and put those drivers in and then even get the C drive working for it. But honestly, I've never done that. So, and with Exchange, it's not supported to have a paravirtual for the C drive, so don't do that. Now, the interesting thing is, when do we want to use this paravirtual? Well, you want to use it only under high load situations. And we actually did a test on our SAN using JetStress, and we compared the LSI Logic SAS to the paravirtual. We've got 10 gig network, we've got SSDs in our SAN, we've got pretty good throughput, and we built a VM and tested it, and what we noticed is that we had basically no difference between the paravirtual and the SAS. In fact, the SAS was a tad bit faster. So maybe we needed a better SAN or better network than our 10 gig E, but it actually kind of surprised me. So interesting. Now here's where it also gets interesting. I don't care how many physical controllers you have on your computer. When you build a VM, it starts out with a single virtual SCSI controller. I then add a hard disk. That hard disk is now attached to that single SCSI controller. Add a second hard disk. It goes to that SCSI controller. In fact, the first 15 hard disks by default go on that first SCSI controller, which is SCSI controller 0. No big deal. But what if we added additional SCSI controllers? Well, no, not true. What if we added additional virtual SCSI controllers? We're not adding any more physical controllers. So why would this matter? It's just a virtual controller. Okay, I could see if we had more physical controllers, we map the virtuals to the physical, but we're not doing that. We're just going to these virtual controllers. Now we're taking these 10 hard disks that we had, just like in the previous slide, and now we're distributing them between the different SCSI controllers that we have. Okay, but what's that really going to do for us? Well, when we look over here with JetStress, which is a tool from Microsoft, a free tool that you can get, and you can run and put a stress on your disk subsystem and see how it performs. So over here, we had a single LSI SAS controller. We have 5 VMDKs, which means we attached 5 hard drives to a virtual machine. And then we had 5 databases, 1 on each hard drive. Now, in this scenario, we'll notice that our latency values were as high as 66.6 latency and as low as about 10 seconds latency there. So a real variable in there. What I find is and that's for the read latency. If you look at the write latency, look at that, 103 down to 9.5. So a lot of latency in there. Now, the next 2 columns I find are really interesting. If you look at let me point this out here. If you look at this column right here, that's the read I/O per second, and this is the write I/O per second for this one VMDK. And if you add the reads and the writes between all of these, we get about 2,900 IOPS total in this particular scenario. You'll also see down at the bottom, we had about 62 page fault stalls. Now, by splitting it up into 3 LSI SAS adapters, same 5 drives, same 5 databases, look at our latencies here. Every single one of them was below 20 milliseconds. Same thing over here. We didn't have a single one. And before we were up over 100. And then look over here. Our IOPS almost doubled from 29 to 52. We didn't buy any new hardware. We didn't rearrange our databases. We didn't move mailboxes. The only thing we did was we redistributed these virtual hard disks between different virtual SCSI adapters. Real interesting. And look at our database page fault stalls down here, down at 0. So for anything, and this is not unique to Exchange, but for any high read-write thing that has lots of hard drives, you might want to look at distributing the load across multiple virtual SCSIs. And it's interesting how it works because, again, like I said, we didn't put any more additional physical SCSI drives in the computer. or SCSI adapters, just virtual. So very interesting that it does that. One of the biggest problems I see when I go into companies, and I'm not going to limit this to Exchange, but when we look at virtual machines, most of the time people build them too big. And the question I have for you guys, if I was going to build a domain controller for Windows 2008 R2 for 250 users, and that domain controller was going to run DNS, DHCP, and regular domain controller stuff, how big would I make it? How many CPUs and how much memory should I give that guy? And I want you guys to post that up there in your questions and answers. How big do you think we should make it? Let's just see what you guys think. So 250 users, 2008 R2 domain controller. How many CPUs and how much memory would we give this guy? 2 gigs of RAM, okay. And this is for 2008 R2, not the core edition, the full version. So one person said 1 virtual CPU, 2 gigs of RAM, okay. Any other ideas? 8 gigs of RAM, 1 CPU, okay. Anything else? 2 virtual CPUs, 4 gigs of RAM, okay. Here's my answer. You know, whatever you choose, monitor it and make it bigger or smaller based upon what you're doing. But if we go over here and look at a real environment with the exact specs of what I'm talking about, here's my environment here. We've got 667 virtual machines running over here on 5 hosts. And if we look at my virtual machines, let's see. I actually have VMware pinging me on my phone. That's what keeps dinging. Here is this domain controller that I spoke of, domain controller 1, and it's running single virtual CPU, 500 megs of RAM, 500 megs. And if you look at this guy, it's using 19%, let's just say 20%, so it's using about 100 megs of active memory at the time. And look how much CPU it's using, 23 megahertz. That's half of a 386 DX40, so that's pretty awesome. And we have another one that's doing that. How about this? Exchange, I hate to say it, 2010. We're getting ready to go to 2016, but 2010 right here, running in a DAG with another Exchange server here, 250 mailboxes with our largest mailbox being 70 gigs. And look what it's doing. 2 procs, 3 gigs of memory. Whoops, where'd we go? And you look at that and go, well, man, you've got to be undersizing that guy. Well, am I? It's using 21% of the 300 gigs. So it's using about 600 megs of memory, and it's using about 215 megahertz on that cluster node. If you look at the other one here, we're using 95 megahertz and about 20% of 3 gigs. So why do I need to make it bigger? It's using 600 megs. Doesn't make any sense. Now, I'm not trying to undersize your VMs by any means. If a VM needs memory or CPUs, I'll give it. Look at this hog right here. This guy's a monster SQL server, millions and millions of records, and it's got 158 gigs of memory. So I'm not afraid to give memory if we need it. And you'll see it's using about 2,600 megahertz of CPU, and we've got 3 CPUs assigned to it. And it's not like my host. I've got plenty of resources on my host. If you look over here, my host have 40 processors, hyper-threaded to 80, and I've got about 500 gigs of memory per host. So I've got plenty of memory and plenty of CPU on my host. It's just you want to make them as efficient as possible. And everything we've learned in life is different when it comes to VMware. Well, what do I mean by that? Well, I always go back to the Verizon commercials that they used to have on TV where they had the little kids sitting around and they had the question asked to the little kids, so do you want a big coverage map or a small coverage map? Do you want, and they're a big car, a small car, and everything was like bigger, bigger, bigger. And in life, that's what we're taught, make everything in bigger. And if I'm building a laptop, that applies. Do I want 4 gigs of RAM or 8? Well, 8. Do I want 16 or 8? Do I want 32 or 16? Well, more is better in that scenario. But when you're building a VM, less is better. Less CPUs is better. Less memory is better. Not to the point of undersizing it, but not to the point of oversizing it. You have to right size it. And that's where I see a ton of problems with companies. Going a little bit more in here, why is it a problem? Well, number one, by adding too much memory, who cares? I'm just wasting memory. Well, no, you're not. You're wasting lots of things. You're wasting hard disk space. It takes longer to vMotion. Your VM will actually run more inefficiently. If you look at CPU, who cares if I have 8 CPUs or 4? Well, this is huge difference over here. If we have a system set up, whoops, and let's say we've got, come on now. All right, so let's say we've got a line here, and we've got a physical core here, or socket. So we've got 2 cores here, 2 cores here. So a crappy system. And let's say we've got hyper-threading going on. So we have the capability to run 8 threads over here total. I know it's a dual 2-socket box, so it's pretty crappy today's standards, but we can run a total of 8 threads. Now, if we build the management over here, the VM kernel, it's always going to use core 0, thread 0, socket 0, everything 0. Now, let's say we go out here and build a VM and give it single virtual CPU. Well, it's going to jump over here. Build another VM, single virtual CPU. It's going to jump over here. Well, I'm going to go over here, build a VM over here, and give it 2 virtual CPUs. It's going to go here, and it's going to go here. Awesome. Now let's kind of change things up a little bit here. I build another VM over here. In fact, I'm going to build 2 VMs. I'm going to build a blue, and I'm going to build a green. Come on. All right, so we've got 1 CPU in green, 4 CPUs in blue. The only thing I want to do in those VMs is open up Notepad. Okay, well, as minimal as that is, it still requires a CPU to perform that task. Well, I have got 1, 2, 3 available threads. So we'll call this VM number 1 and VM number 2. VM number 1 could jump in and grab any one of those CPUs immediately. And it could just start working, no big deal. It could open Notepad. VM number 2, though, it has 4 virtual CPUs. Well, so what? It only needs to open Notepad, which takes all of about 5 megahertz. So who cares? Well, VM number 2 will do nothing until at least 4 threads open up. So it's going to have to wait for one of these other machines to finish, so now he can use 4 threads, even though he's just opening up Notepad. So let's assume that VM number 2, we gave it 4 CPUs, but let's assume it never used more than 1,000 megahertz of CPU ever. And our CPUs down here are 2.4 gigahertz CPUs. How much time is this guy going to have to wait to get access to the CPUs? And what if we built all of our VMs with 4 virtual CPUs? And think about this, because this is very common for companies to give every VM 4 virtual CPUs. Well, the VM kernel, well, this is the VM kernel, so it's not a VM. It's always using this one guy down here. So that leaves us basically 7 threads. So if VM number 3, 4, and 5, if I've got 3 using 4 threads, man, I couldn't do anything with 4, 5, 1, or 2. I have to wait for 3 to finish, and basically I'm accomplishing nothing. I had a guy one time in class with a dual quad-core box, no hyper-threading. So he had 8 total cores, just like this here. His consultant came in and set it up for him and gave each VM 8 virtual CPUs and 32 gigs of memory total. And his physical box only had 32 gigs of memory. And he said, Sean, I got several problems. Number one, my VMs are running like crap. Number two, I can't vMotion my VMs from one host to the other. And I said, well, how big is your environment? How many total users are you running? He goes, about 30. I said, okay. And after looking at my domain controllers, he was kind of like, yeah, dude, our domain controller has 8 CPUs, 32 gigs of RAM with 30 users. So we looked at it and saw what it was using. And for CPU, it was using about 100 megahertz. For memory, it was using about 200 megabytes. So we looked at it and said, you know, we can resize that guy. We looked at the other, because he's running 5 VMs across 3 hosts. We look at the other VMs in his environment, and they're all the same thing, all way oversized. We brought them all down to where they should have been, which was 1 CPU and 1 gig of memory. And we then were able to consolidate all 5 VMs onto one host. Performance went through the roof, and he was using less than 10% of the CPU on one host and less than 25% of the memory on one host. So it was really amazing how well it was working in that environment by bringing the CPUs and bringing the memory down. And that's one of the biggest things I see people do wrong. So right size your environment. That's not unique to Exchange. That's unique to VMware. People build them too big. So we built this class, and it's pretty neat. What we did was we went through and we said, you know, Microsoft built a couple of classes called the 341 and the 342. One is on administering and one is on designing. And we took the relevant information from those 2 chapters, kind of got rid of the junk, the overkill, the redundancy, and combined them into one course. But their courses were all running on Hyper-V. Then what we did was we built an entire new environment on VMware. Now, another thing we did that was interesting is in the Microsoft classes, they had over 25 instructor demos, which is basically watch me and you'll see what we do. But you're not going to do it. Just watch me. And what we did was we took those demos and took the concepts and said, let's make a lab out of this. So we have over 42 labs for students to actually perform. Almost 40 to 50% of the class is labs. In fact, one of the labs we developed, which takes about 4 to 6 hours, is we have the student do an entire migration from Exchange 2010 to Exchange 2013. So they have to set up the 2010 environment and do the entire migration, the connectors, the CAS servers, the certificates, the mailboxes, the public folders, and then decom the old environment. And the cool thing is we take our environment and we make it available to you not just during the day of class, but we make it available to you for up to 1 year following class. So if you want to do that migration 100 times, knock it out. So who did we build this class for? Well, obviously people running on VMware. But that's not everybody. So if you're running physical or virtual, Hyper-V or VMware, we discuss what you need to do to virtualize your environment. Even though Microsoft's running on Hyper-V, they don't talk about what you need to do to even virtualize it on Hyper-V. So we get into that. If you're looking to take the exams, I actually wrote the exams for Exchange 2007, 2003. I did that. I kind of got away from doing that stuff and got into VMware consulting and things like that. So I didn't write the 2010 or 13 exams, but we do have prep stuff for that if you're into that. We've consolidated into an intense 5-day course, about 10 hours a day, so it is pretty crazy. And one of the big things, I do consulting. I go out next week. I'm going to Apache Junction. I'm doing a consulting job for a company out there. Then I'm going to Kingman doing a job out there. Then I'm going to Los Angeles doing a job out there. When I teach the class, you're learning for somebody who doesn't just read from slides and doesn't just read a book on how it works. You're learning for somebody who goes out and screws it up and plays with it and does it. And I'm comfortable in my many years of consulting to say, yeah, when you're out there doing it, you definitely learn more than you do just reading a book. So how else is our class different from the Microsoft official stuff that you can get from New Horizons and things like that? Well, we not only cover Exchange, But we talk about what you're going to run into in the real world. We talk about the dreaded Bez server and what versions of Bez you need to make it work. What about GoodLink and how that works? What about load balancers? What about if I'm running a NetScaler or an F5? How do I make those work? What about replication to my DR site? How does Riverbed tie into that if I'm running that? What about NetApp? We actually have a section on NetApp where we talk about Snap Manager for Exchange and SnapDrive and SnapMirror and Recover Point from EMC, and we get into all kinds of different stuff that I guarantee you won't get anywhere else. We cover your storage, networking best practices, your backup. We talk about different backup products that are available, everything from Symantec, Backup Exec, Net Backup, Veeam, all kinds of cool stuff. Like I said, the labs and the instructor are available after class is over. I've taught the class about 13 times or so in the past year, and out of that, I've netted about 6 consulting jobs. So I'm not saying I'm doing this to get consulting gigs, but it just kind of works out that way. And all of our classes are taught by real-world Exchange and VMware instructors or consultants. So for Exchange, I'm the guy that teaches it. For other classes, we have other people teach it. You know, the next line is subjective. We feel we're the best class in the world for Exchange, but you know, everybody's going to tell you that. So great, whatever. The next line is not subjective, though. We are the only class in the world teaching Exchange on VMware. Nowhere else does it. Everyone else is doing Exchange on Hyper-V. So we did some pretty cool stuff there. So let's see. Here's some of our other classes. You know, all kinds of different stuff. And if you want more information, contact your sales rep, and we'll go over that. So, and there's our information, some of our webinars. So let me see what questions we have here. So someone mentioned something about being a CVE from the certification standpoint. When you're taking a Microsoft class, there is no requirement to take a class to go take a Microsoft certification. There is no requirement with that. So with VMware, there is a requirement, and Folco, if you're interested in getting VCP certified, we do have programs for you to help you get VCP certified if that's something that you're interested in doing. You might want to follow up with Jenny, and she can help you with that. So that is one thing that we do have available. So I am VCP certified, VCAP certified, and things like that. But yeah, as far as Microsoft goes, with any of these, we take the actual Microsoft exams. Yeah, it's kind of crazy with VMware. They just make a requirement. You sit their class. I've had students that go out past the VCP, do awesome, but you still have to sit the class even you know everything about it. So it's not my requirements, theirs. Any other questions? I'm going to stop the recording.